Hey everybody, this is Alex Merced from alexmercedcoder.com, and in this video what I want to do is talk more about Docker. So in the last video we saw, okay, hey, I can go look at the Docker hub, look up a container, pull the container, run some code against the container. That's all well and good. Okay, and there's a lot more stuff you can just do with that. Okay, and that's wonderful. But there's a documentation. The idea here is just to introduce you enough so that way you can go in there and feel comfortable diving into the documentation and exploring it. But in this video, we're going to talk about how you would create your own image from scratch. So, like, let's say you wanted to create a new Docker image that represents a image that you would like, a specific set of like tools that you want in a container that you want to be able to just turn on and off. How would you do that? Okay, so the way we would do that is you would create a file called Dockerfile. You could really call it whatever you want, but by default, it's going to expect a file called Dockerfile. Okay, and basically, I have this sample Dockerfile that I created for my Java Scala image that I use for doing a lot of like data work. But basically, what you do is you always want to start from another image. So there's different versions of like Linux and other operating systems you can find in Docker Hub. So you find some image that you want to start from. So I want to start from the Ubuntu operating system. So in this case, I'm just gonna copy this over since I got it right here. Okay. So I'm saying, hey, starting from this image, so this is just a blank Ubuntu operating system. And when you see these blank, CentOS or whatever Linux version you want images, they're always minimalist, meaning like they really have like nothing installed. So things that you expect to be installed in a Linux operating system out of the gate, things like curl and whatnot, wget, etc., they're not there. They're not installed yet. So you do have to make sure that first thing you do is install things you're going to need, like wget, all that stuff. So the next step I would do, and actually the next step I would do is I would create a non-root user, because generally you don't want to have a root user doing things in a Linux operating system, because a root user can access sensitive things and whatnot. So even in a container where it's isolated from your actual computer, this container could be running someone's application, and you just don't want to create any vulnerabilities. So this code right here would handle creating the non-root user, but let's kind of go through it. So each of these run commands, so from, these are the keywords. So these purple keywords are the actual, like, the language that is like a Dockerfile language, like the words that are built into how Docker reads a Dockerfile. So the from just means, hey, starting from this image. So I'm saying starting from Ubuntu. So then it spins up this image, and then it's going to begin executing commands against it. And the run are just normal commands that would run in bash. So like imagine like you're installing stuff on your own Linux machine. How would you do that? Okay, so again, on Linux generally, especially in Ubuntu, you're going to use like apt, the something package, something. Okay, but you're going to use apt. So I'm going to say apt get, that's kind of like the command saying, hey, I want to install something. And I'm going to do apt update. That's the first command I'm going to run just to make sure that it has the latest version of all the repositories. And then again, the 2 ampersand. So this is all just bash. This is just me typing in commands I would normally just type into bash. So run is just saying, hey, run the following command. So I'm updating apt. Then I'm doing apt get and installing sudo, because sudo's not in there out of the gate. And I'm installing wget. And I'm installing curl, because these are just things you're going to need to download and install anything else, and they're just not there out of the gate. Now, the thing to keep in mind, notice how I keep putting the -y flag with .get, because the thing is that when the Dockerfile is generating the image, a lot of these installs are going to ask you like, hey, are you sure you want to install this? They're going to ask you questions, and there's no way for you to respond to the prompt. So this -y flag for a lot of commands in bash will automatically say yes to any prompts that come by. So by adding this -y flag, what it's doing is just saying, hey, when I ask you, like, are you sure you want to install all this? It's going to automatically say yes. So that way, when it builds a Docker container, it doesn't fail. Because it will fail because it'll just get stuck on that step because the computer's waiting for you to say yes or no. You can't respond, and it just times out. So that's why I'm putting these -y flags here. But I'm installing these things because wget allows me to download things. Curl will allow me to do like some tests if I need to do some tests. Also allows me to download things. And yeah, sudo is just so that we can do sudo, so this new user can use root privileges without being the root user. Then I'm going to run this command to add the user to the Linux machine. So user add is just the bash command to add a user. So I'm adding a user called Docker. Okay, and then what I'm doing is here is this: I am changing the password of the user. So I'm saying, hey, the password of this user is Docker. Okay, and then I'm adding the Docker user to the sudo user group. Okay, again, you can just literally copy this. I will put this somewhere on GitHub when we're done, so that way you can use this as sort of a template to start from. And then here we're just basically, actually here you're setting up so that way you don't need a password. That's what this is doing. So it won't ever prompt you for a password when you use sudo when you run that. Okay, so that's all set. So now that I got that set up, now the question is, I want to install everything under the user. So I'm going to want to switch to the user. So what this does, so this user command, what it does is that it'll switch the context to a different user. So by default, it's going to use root user. I don't want to be root user going forward because again, you want to always isolate away from the root user for security purposes. So this switches, so every thing going forward is going to be doing the commands under the user Docker. So today we're going to keep it simple. I just want to install Python. Okay, so I think I have a Python install already here to keep it simple. Install Postgres. So if I want to install Postgres, so you see here, like I can add comments using the hashes. So I left comments and saying like, hey, these are the different things that I did. Okay. Okay, that's all good, but I just want to install Python. Did I have Python as its own section? Here we go. So here's installing Python. So now I can just begin like installing things. So here I'm just going to install Python and pip. And once I've done that, that's going to be pretty much all I really want to be done for this container. I just wanted to kind of like install Python, but maybe I want to install Ruby and other things along the way as well. And then you can sit there and set the working directory. The working directory will be where like this thing starts. So if you wanted like to start in a particular folder, which in this case I wanted to start in the folder for that user, I'll use this. So workdir means, hey, this is going to become the new sort of main folder in the container. Okay, going forward in the Dockerfile. So initially it's going to be the root folder, so slash. But in this case, I can specify saying, hey, going forward, all commands that I run are going to be in the context of the home/Docker folder. And then what I'm going to do is I'm going to run the bash command to open up bash. So whenever the entry point means what command do you run when you start up the container. Now these are all things I can override when I spin up a container. There's flags you can pass in to say, hey, you know what? Whatever the entry point is, I'd rather do this as my entry point. But again, you can put stuff in the Dockerfile. So if I add this there, again, I'm going to set that working directory and you're all good. Okay, so now what I would do, I'm going to open up my terminal here in VS Code. Okay, I'm using Visual Studio Code, by the way, if you didn't already know. And the command would be docker build. So that means I want to build an image. And it's already going to assume that I'm looking for a file called Dockerfile. So if you called it Dockerfile, just Dockerfile, it should be fine. I don't have to specify a name. Otherwise, you do have to specify like a name of the file. Like you have to pass a flag and be like, okay, hey, I want to build this specific Docker file. Simplest thing is just you have a folder, one Docker file, build it in there. Okay, and I need to give it a name, and the flag for giving it a name is escaping me at the moment. So docker build command. Okay, the documentation, always helpful. Okay, got it. Nope. But I want to give it a name. So where is the command flag for giving it a name? File. Like this is if you want to specify a specific file. That's there. Set metadata for image. So you can see there's a lot of different flags you can include there. You can include tags. All that stuff is good. I really just want to add a name. It's not label. Secret, squash, SSH, stream, target. Actually, I think the name comes in when you publish it to Docker Hub. So we'll go over that in a second. I would say docker build, docker build dot, and what that's going to say with docker, the dot means like where is the Docker file. So since I'm not specifying a file that's not called Dockerfile, I don't have to pass in that -f flag. So I just put dot, meaning the file is in the current folder. So dot always means the folder that you're in. And the folder that I'm in is inside this Rails 101 folder, which probably should have called it Docker 101 folder, but whatever. Docker build dot. So if I run this, see now it's running through it. And notice like it skipped a lot of the steps. The reason being is that I've built other images with these exact steps, and it picks up on that. It'll be like, hey, I have other containers that have done this step and this step already. So I can just pull those snippets from those other containers, and I can build this pretty quick. So now it's only doing the parts that it knows has to be done differently. And see, I get an error. So I do is I'll investigate. And you might have to do this several times before you finally get the image successfully created. But once it's done, it's done. So let me see what the error was. Packages will be installed. Did I forget the -y flag somewhere? Fail to fetch security. Python. Fail to fetch. Okay. I think there was some step that was necessary that I skipped. Over here, yeah. Right here, there's some stuff here. So I do kind of want that, because I did that up in this step for this particular image. I think that is good. Let me just do another quick read through here. Yes. Well, that install anything else Python related? Anywhere else? I don't think so. There, I installed Java. So let's put that there. Okay. Let's try that again. Okay. So far, so good. And it doesn't like that either. Okay. Maybe I need to do an update. So let's add a sudo update onto that. Sudo apt-get update, and just one update should be fine. But just in case, let's just try this out. See if the first one runs. Okay, that's looking good. Okay, and generally this is how it goes. You build the image, and what you're trying to do is kind of monitor the output to make sure that all the commands ran fine. But once the image is done, now you have this image that you can just spin up on any computer, and you have this environment created, and that's kind of like the beauty of it. Okay, and then later on in the next video, we'll talk about Docker Compose, where I can actually start orchestrating multiple containers, which is also really cool. Okay, and other things to kind of keep in mind is that like maybe you plan on doing like a particular set of development. You might be using like let's say Python Flask or something. And so you're gonna you want to be able to access that web server inside the container. Then what you may want to do is use like there's a command called expose that you can put here, and I can say, hey, you know what, I want to expose port 5000. Okay, and then what that's gonna do is say, hey, you know, port 5000 is visible to the outside world. So then when I run the container, I can then map that 5000 in the container to a port outside of the container to my computer, so that way I can access that deal. The only thing to keep in mind though is that inside the container you have to make sure that the host of your server is 0.0.0, not localhost. Okay. The reason for that is that by default, when you're using like web frameworks like Flask or Node, specifically Express or Koa or something like that, Ruby on Rails, by default they generally use like localhost and some port. Localhost is a pseudonym for the IP address of 127.0.01. And that IP address allows you to run code locally, not from externally. So other computers cannot access ports on your local host. On And for all intents and purposes, this container is another computer, as far as the way your computer understands it. So generally, if you want to run something locally and have other computers be able to see that application running on whatever port, you have the host has to be 0.0.0.0.0, which means, expose it to the rest of the world. It's a public IP address. So just keep that in mind, because a lot of times people will build the container, they'll expose the right ports, then they'll run the app and it just doesn't work. And they're wondering why? Everything seems to be connected, right? I'm calling the right port. The app is running inside the container. Why is it not working? It's because oftentimes the app in the container is serving it up on port 5000, but on 127.0.01 localhost, not on 0.0.0.0. So just that's going to be called changing the host. So again, every time you use one of these web servers frameworks, there's the host and then there's the port. The port can be whatever you want, but whatever port, you want to make sure you expose it. So that way that port is exposed to the outside world. You can also just do that through your commands. When you do Docker run, you can just say, hey, map this port to that port, so that you can do that. But make sure that the actual application uses host 0.0.0.0. So just keep that in mind. As you can see, this is going to take a second, so I'll probably pause the video while that finishes. Okay, so as we can see, this completed building. So now we have this image built. So now if I type in Docker images, Docker image PS, or actually ls. Okay, I should be able to see this image somewhere. Okay, yeah, so this is the one I just created. Okay, it doesn't have a name. Okay, so see, I created it about a minute ago. Okay, but I have an ID, so I can use the image ID to run it. So I can be like copy. I can be like Docker run, put it in IT mode. So okay, and see, I'm inside the container now. So notice my prompt has changed. See, I'm inside the container, and the container's running, and I can do things like just right now I'm in Bash. But if I do Python 3 -- version, see Python 3 is installed, Python -- version, Python 2 is installed. So the things that I expected to have installed in this container are installed. So just again, imagine you have a container you pre-install all the things that you want to have, and from computer to computer, you can just spin up the same exact environment to work out of, which is really, really cool. And again, you can move an application into the container because you can copy files into containers. There's a lot you can do here to create just a snapshot of your application that you can just run from computer to computer without having to worry about the operating system and all these kinds of factors. So I'm going to exit now. Just type in exit. That'll get me out. Now let me just check if that left the container running. So Docker container PS. Nope, the container's off. Okay, and then you guys get the idea. So that's kind of how Dockerfiles work. That's how you can create a fresh container that's custom to what you want to do. Okay, and then this file here is just sort of again a sample of that. So I will put that up on GitHub and link it in the video description. But have a great day, and I'll see you guys in the next video where we'll talk about Docker Compose.